right, in this video we are going to continue working on the add method. We partially implemented this in class previously. This is the version of add where we wanted to add at a particular index. So basically like an insert. I'm inserting an element into the list. So we kind of have to shuffle things down further into the list when we do that and move things around. So we did that and just kind of remember how that would go if I run this and populate this list. So here I have this list, and then I want to do words.add 0j. So that's going to insert a j into this first node that's in the list, and it's going to move all of the rest of these down a little further. Right. So how that's going to work, or how that happens, is that we create a new node with the element that we want to add. So that's j right here. So here's the new node. And then if index is 0, so in other words, if we're going to insert it here at the beginning, then all we need to do, right, is number one, and the order mattered here and how we did this, right? We need to make the new node that we created, we need to make it point to the same node that the current first node points to. That's actually not the same one, but to point to this head node right here, okay? So all we have to do is say, hey, this one is the next. So right now, the next element of that new node is empty. We're going to make it point to the head here. So that's the next step right here. New node dot next equals head. So this is going to start pointing to this one. Okay, and so now that this node, right, is pointing to the head, then I can adjust this pointer, the one that was pointing to the head. I can now move it to point down here. Remember, the order there mattered, right? Because if you do these in the reverse order, you're going to lose the rest of the list. It's going to get garbage collected because nothing will be pointing to this first node right here. But now that the new node is pointing to this new node, the garbage collector will not see that as a dead reference, and that memory won't get garbage collected. So now we can adjust this node head to point to the new node that we created. So everything's going to kind of get shuffled down in the list like that. Okay. So that's the case, and then we increased size by 1. Okay. So that's inserting in the front of the list. So now what we want to do is to make it so that we can insert at any one of these indexes here. Okay. All right, so let's take a look at what that would look like and the things that we would have to do. So let's say I had a list that looked like this to start off with, and I wanted to add 2 at index 2, I wanted to add f. So the result of that, right, would be an f at index 2, and then all of this stuff would kind of just slide down and be further down the list. Okay. So what would we have to do in order to do that? So number one, right, is what we've already done there, and we'd have to create a new node. So we would have a node there with whatever we wanted to add. F just kind of sitting out there by itself. All right, and then what we would do is we would use the getNode method, which we wrote last time in class, right? So remember, getNode will allow us to locate a node in the list given an index in there. So that's what we want to do. And what we want to do is locate the node before the one that we want to add at. So second step, locate the node prior to the index where we want to insert. All right, so that would be step 2. So picture-wise, right, that would kind of look like this. I'd have head, and then A, B. So B, right, would be the node that we want to pick out using get node. And right now the list looks like this. Okay, so we have this node picked out, right? And then now what we need to do, and we have the new node just kind of sitting out here. And then we just kind of repeat the steps, right, that we did before. So step number 3, right here. Let's see if I can. So that's step 1, create the new node. Step 2, locate the node just prior to where I want to insert. Step 3, is what we want to do is make this new node, right, point to this node right here that's going to follow it afterwards, right? If you take a look and see here, I've got after I've inserted the F at the index right here, that node C is the one that's just after this one right here. Okay, so that would be step 3. So that would be make new node. Point to nodes next. So next node is this one that we found that's just prior to where we want to insert, right? And so we can figure out where it's pointing to and then make the new node point to that one. So that's number 3, step 3. And actually, probably should write this like 3 over here. And then step 4, make node, the one before, point to the new node. So right now it would kind of look like that. After step 3 it would look like that. Then what we're going to do is change this so it's not pointing there anymore, but so that it's pointing right here to this one, like so. Okay, so those are the steps that we would need to do in order to go from here to here. Okay. All right, so let's see if we can implement that in the code. Step number 1, create the new node. All right, so that's already done. We already did that up here, right? We have to do that in either case. Okay, so I'm just going to leave that up there. Step 2, locate the node prior to the index where we want to insert. All right, so this has to be in an else clause here. Notice, right, we have to treat these two cases differently, right? Because you can't do that when you want to insert at the first node. There is no node prior to that one, right? So we have to treat those two cases differently. There's just no way around it. All right, I'm going to declare a variable here of type node, and I'm going to call it just node, and that is going to be get index of index -1, right? go out and find the node just before where you want to insert. All right, and so this will have a reference to that. Now up here it says throws an index out of bounds exception if the index is out of range. So that will be taken care of by get node right here. So we don't have to worry about that in this one. We certainly wouldn't have to worry about it with the index 0. That's always going to be a valid index. So we wouldn't need to throw an index out of bounds exception with that. Okay. All right. So that is step 2. Locate the node prior to the index where we want to insert it. Step number 3, right, is we want to take that new node and make it point to wherever node was pointing to. Okay. So that's going to be take the new node, so we're calling that new node, and make it point to, so in other words, adjust its next value to whatever node is pointing to. So make new nodes next equal to nodes next. Okay, so that accomplishes step 3. All right, and then step 4 is make node point to the new node. So we need to break this link here and establish this link right here. So that again is going to be adjusting nodes next. So node.next equals new node. We want to point it to the new node. And then I forgot to put this on the outline, but we would need to increase the size by 1. You can see that we're already doing that here. Okay. Again, the order in which you do this matters, right? You don't want to break this link too quickly, because if you break this link before you establish this one, the rest of the list is going to get garbage collected, right? So you don't want that to happen. Okay, time to test this out. So let's add words.add 2. Okay. Let's see. Let's get node, not get index here. Sorry about that. All right, let's run that in Canvas and just check everything out. So, okay, so here we're going to add 2 at index 2, so 0, 1, 2, right where this B is at, we're going to add a K. That B should shuffle down here, right, like so. All right, so if we step into this, we create the new node. There it is that we need to add. If index is 0, it's not, right, so it moves on to the else case. Get node. And then that would be index -1. So that would be 2 minus 1. That would be this A. That's the one right before. So we should see that pop up. Okay, so now node is pointing to the one just before. Next up, we're going to alter new nodes next. So we're going to make this new node, right now its next is null. We're going to make it point over here. So there we go. Now it's pointed to that. Now the rest of the list won't get garbage collected when I break this link, which I'm about to do. So I'm going to break this link right here between A and B and make A point to K, and you're going to see that's going to place that K in the correct spot in the list. All right, then increase the size by 1, and there we go. Okay, that is it on this one.